This is going to be a bit of a long section. It has a lot of stuff, but sit tight, be patient, take notes, and split up the videos. Don't watch them all one after another. So we're going to start talking about composition of functions, different ways that we can combine functions in different ways. And I'll just say it multiple times to pretend that it was intentional. In a lot of different ways are we going to combine functions. So we're going to start by talking about 4 of them. These are the 4 easier ones, and then in a future video we'll talk about the 5th one. So we're going to start talking about algebraic operations. Plus, minus, multiplication, divide. And things look a little weird here, but they behave exactly like you might think. So let's start with the definition. Definition. When I write f plus g of x, this is just shorthand for f of x plus g of x. Okay, so this is one way that we can put functions together. We can add them together. So to add 2 functions together, we just add their individual function values. Okay, so this is a new function, right? This is a new function, f plus g. And to get this new function, you just add the old functions. All right, and that's kind of what we're doing right here. And so very similarly, if I have these other functions that I write down, f minus g of x, f times g of x, f divided by g of x, I would hope that you would be able to translate this first definition into the other 3. Hopefully this is not a surprise. Hopefully what I write down here is not going to be a surprise. F of x minus g of x. Okay, so it just does the same thing, right? F plus g is add the individual function values. The new function f minus g will subtract the individual function values. Okay? And similarly, f times g is just multiply these function values, and f divided by g is just divide these function values. And then, of course, this last function is only defined when the denominator is not equal to 0. Remember when we talked about domain and range? Domain and range just has to do with what are the things that you can plug in. And well, we can't plug in any x value that causes the function g to equal 0. Because if this function g equals 0, then we're going to be undefined because we're dividing by 0. So these are our 4 new functions. Let's use them, okay? Example 1. You know what? Pause on example 1. Very important note to make right here. We'll make it later. Can't be that important, right? All right. Example 1. Find the following. And specifically, find the following for, let's say our f of x here is the linear function x minus 1, and g of x here is the quadratic function x squared minus 1. And in part A, I want you to find what is f plus g of 2. So the problem tells us what f is, the problem tells us what g is, but this new function f plus g, we don't know what this new function is. This is a function that's not given. But we have the definition for it. This new function f plus g is just the old function added together. So this is the old function f, also evaluated at 2, plus the old function g, evaluated at 2. This is the definition of adding functions together. Okay? So be very careful. And this is just the definition from the previous page. And then once we get here, well, we can evaluate these functions like before. F of 2 means you plug in 2 into the function f. So f of 2 is going to be 2 minus 1. And g of 2 is going to be, we'll plug that into g. g of 2 is going to be 2 squared minus 1. Right, again, this is just f of 2 is this, and g of 2 is that. And now we simplify. 2 minus 1 is 1. 2 squared is 4. Oh, the 1's kind of cancel here. Positive 1 minus a 1. F plus g of 2 is just equal to 4. All right, and that's function addition. That's one way that we can put functions together. Let's do a couple more real quick. So we can also do something that looks a little weird, f plus f of 1. Just use the same definition. The first function evaluated at 1 plus the second function evaluated at 1. It doesn't matter that they're both called f. We could be f plus f, f plus g, g plus f, g plus g. What matters is the definition of what this means. Okay, so f of 1, that's just plugging in 1. 1 minus 1. Plus f of 1, well, that's plugging in 1 again. 1 minus 1. And this cancels out to 0. Part C. What is the function f minus g? There's nothing to plug in here. It just says, what is this function? So the way that we describe a function is by telling you how it works. So the function f minus g, that is a function that takes in x values. And it takes in x values, and this is what it puts out. F of x minus g of x. So this is the name of the function, and this is how I describe the function. What is f of x? X minus 1. Minus g of x. X squared minus 1. And I've made a mistake here. In this last step, I've made a mistake. The mistake is that we're supposed to be subtracting the entire function, g of x, but I'm only subtracting the first piece. To subtract the entire function, we need parentheses. Okay? So don't forget the parentheses, because we're subtracting the entire function. For addition, right, we could have had parentheses here too, but for addition, you don't need parentheses, but for subtraction, parentheses matter. So this becomes x minus 1, distribute that negative, minus x squared, plus 1, and again, the 1's cancel. Now we're just going to get x minus x squared. There's a couple different ways of writing this. If you wanted to write it as negative x squared plus x, that would be okay too. All right, and that's the idea here. You could continue this with the other ones, but they'll all work pretty similarly. So I want to pause real quick to talk a little bit about set intersection, and then we're going to talk about how to find the domains of these functions. The domain of this new function, the domain of this new function over here. But real quick, let's talk about set intersections. So intersection, a lot of times it's called with that notation. That's the intersection of sets is what they have in common. Okay, so if I look at some examples, like example 2, and I say find these set intersections. So the set 2 to infinity, this is interval notation, but it represents a set. This represents a set of all the numbers between 2 and infinity, not including 2. If we intersect that with the set negative infinity up to 5, what happens? Well, the intersection is just what they have in common. So let's look at a number line. Say 2 is over here, 5 is over here. So one of these sets, right, you can either use a parenthesis or an open circle. One of these sets is all the numbers from 2 up to infinity. And another set is all the numbers up to 5 and down to infinity. So intersection is just what they have in common. What's the overlap between the red and the blue? Well, if we combine the red, I don't have purple. I don't have purple on this app. But if we combine the red and the blue, red and blue is going to make green here, then their overlap is this interval, right? That's the intersection right here. Red plus blue equals green. Things you learned in math. It's not. I'm lying to you. So this is the interval from 2 to 5. And that's the answer, and that's how we do intersections. So let's do a couple more examples to really kind of hone this in. Intersection of 0 to infinity and 2 to infinity. Let's get our number line. Say 0 is here, 2 is a little bit bigger. 0 to infinity looks like this. 2 to infinity looks like this. Where does red and blue overlap? Well, the smallest number they overlap is at 2. And the biggest number they overlap, well, they overlap as big as we want. 2 to infinity is our answer. All right, we can do this more and more and more and more. But let's just do 2 more examples for today. 1 to infinity, intersect negative infinity to negative 1. Draw it on the number line. Negative 1 is here, 1 is there. 1 to infinity looks like this. Negative infinity to negative 1 looks like this. What's the overlap? What does red and blue have in common? Nothing. Right? There's no number that is in both of these sets. We're going to say nothing. There's 2 ways of writing that. You can write it with a Greek letter phi, capital phi, or you can write a set with nothing in it. These are both good answers, and they're both names for what's called the empty set. This is a really fancy math name, the empty set, because it is just a set that is empty. Very great term. There's no intersection between those 2 sets in part C. Let's go to set builder notation. The set of all x such that x is not equal to positive 1. Intersect the set of all x such that x is at least 0. Oh, I'm writing off the board. So let's graph this on the number line. I should have just done this on the next page. The set of all x such that x is not equal to 1, and the other thing has to do with the 0. So let's put those on the number line. Everything that's not equal to 1, that's everything that's less than 1, and everything that's bigger than 1. The second set is everything at least 0. Looks like this. So what's the overlap? The overlap is 0 up to 1, and then 1 up to infinity. So we'll write that. 0 up to 1, 1 up to infinity. 0 up to 1, union 1 up to infinity. And that's set intersections. And we're going to use that when we talk about the domain of these new functions, f plus g, f minus g, f times g, etc. So, property. The domain of f plus g, f minus g, and f times g. We're not listing the 4th yet. There were 4 of them. is the intersection of the domains of f and g. So if we're combining two functions, we just intersect their domains. This new function, the domain, the set of all the things that we can plug in, is just basically what could we plug in before. All right, and similarly, the domain of f divided by g is the intersection of the domains of f and g and the set of all x such that g of x is not equal to 0. So f divided by g is kind of the weird one because there's a third requirement, a third thing that we have to find where all three of these things have in common, because we don't want g to be 0. If g is 0, then we're dividing by 0, which is no good. So let's use this property to finish out this video. Example 3. Find the domain of the following, where f of x equals the square root of x plus 1, and g of x equals x minus 1. And we're going to start by asking you the domain of the function, this new function, f plus g. This new function is just adding the old functions together. What's the domain of the new function? It's the intersection of the domains of the old functions. So if we think of this first domain, the domain of f, we can call it d1. The domain of this function is the set of all numbers from -1 to positive infinity. Go back to 3.2 if you want more information on where this came from. But this is just all the numbers so that the inside of a square root is 0 or bigger. The second domain, the domain of g, this is a line. The domain of g is -infinity to positive infinity. So if we use this property says that the domain of their combination, the domain of their sum, the domain of this new function is the intersection, the overlap of these old domains. So the old domains are like this: -1 to positive infinity and -infinity to positive infinity. What's the overlap? Well, just like before, the overlap is -1 to positive infinity. Oops, with a bracket. And that's our answer for part A. Now I've got some good news. Math oftentimes has a lot of bad news, but I got some really good news for you here. Watch this. Part B. What's the domain of f minus g? How do we find that? The domain of all three of these functions is the exact same thing. Right? F plus g, f minus g, f times g. We find the domains in the exact same way. Let's recycle our answer. Let's use it again. It's also -1 to positive infinity. Part C, what's the domain of f times g? It's the same thing. All right. It's also -1 to positive infinity. Unfortunately, you might know where this is going. I'm now going to ask you for this domain. So the domain of f divided by g is the intersection of the domain of f, the domain of g, and the set of all x such that g is not 0. Well, let's do that next. This new function f divided by g. So it's going to be the intersection of three sets. First one is what we're calling d1, the domain of f. All the numbers that are at least -1. The second set is all real numbers, this blue set, d2. And the third set right? This third set is a set of all x such that g of x is not equal to 0. Well, what does this set look like? What does this look like right here? Well, g of x not equal to 0 is, well, what's g of x? It's x minus 1. So this is all the points where x minus 1 is not equal to 0. Well, add 1 to both sides. That's the point where x is not equal to 1. So this third set is all the points where x is not equal to positive 1. Oops, positive 1, not negative 1. The positive 1 is over here. So this third set is all the numbers to the left of positive 1 and all the numbers to the right of positive 1. Now we need to find the overlap of all three sets. That's going to be over here. So the overlap, the smallest overlap is at negative 1. And then overlap, 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 and then, oh, we can't be positive 1 either. And then all three sets overlap here as well. So this green answer, just like before, is our intersection. It's our final answer here. Our answer is going to be the set from negative 1 to positive 1, union positive 1 to positive infinity. All right, that's the first video. There's a lot of stuff here, a lot of problems to do, a lot of practice. Let me know if you have any questions, and good luck.